Hello, everybody. My name is Mike Zephyr, and I'm an associate professor at the University of Melbourne in the Faculty of Business and Economics. And this is the Quantitative Methods Network, which is an internal group we have here at the University of Melbourne. And we have a usually weekly speaker series here. And today we are extremely excited to have an honored guest, Nancy Cartwright, to talk about, Professor Cartwright, to talk about predicting what will happen next when you act via a causal process tracing theory of change. And let me just say a few things of the many things that could be said about Professor Cartwright, about Nancy. She is a professor of philosophy in the Department of Philosophy at the University of Durham and the University of California, San Diego, or UCSD. She's the past president of the Philosophy of Science Association and the American Philosophical Association, the Pacific Division. She was awarded the 2017 Dr. Martin R. Lebowitz and Eve Lewellis Lebowitz Prize for Philosophical Achievement and Contribution. She's a member of the American Academy of Arts and Sciences, a MacArthur Fellow, and a Fellow of the British Academy, and Professor Emeritus at LSE. She was honored by the University of St. Andrews in Scotland during its 600th anniversary, which sounds like a lot if you're an American, and along with Hillary Clinton and Jane Goodall. And she serves as co-editor of the Center for Humanities, Engaging Science and Society, or CHESS, which is a great acronym, at Durham. And her distinctions include being a former member of the U.S. National Research Council's Committee on Developing a Research Agenda for Social Science Evidence for Use, which is what we're here to talk about today. Thank you so much, Nancy, and feel free to take it away.
Thank you. Well, I'm glad to be here. And this is not a talk about quantitative methods. It's not really a talk about qualitative methods either, because the kinds of things I'm going to talk about require a mix of all kinds of methods to establish in order to use them. The setting, as Michael said for my this talk today, is thinking about predicting intervention outcomes for in evidence-based policy. The kind of thinking that I'm suggesting can carry away from other areas than policy anytime when there's going to be a gap between initiating a cause over here or an action you're going to do and expecting an effect over there. This kind of reasoning can be very appropriate. So what I'm offering in this talk is an alternative to counterfactual thinking, which is in my mind, altogether too widespread way of thinking about causality, and the concomitant demand for randomized control evidence for causal claims. And the randomized control trial evidence is always from elsewhere and elsewhen, even though it's supposed to be evidence for what's going to happen here and now. So what I'm offering is an alternative that via building and evidencing something we call a PTOC, which is a causal process tracing theory of change. And it's not, most of the ingredients in this are ones that are familiar from elsewhere, including some of our own earlier work. But we put them together in a way that I think is should make for as reasonably good predictions. Okay. Now I have said that I have an alternative to counterfactual thinking. Now about counterfactual thinking, I have philosophical concerns, and we can discuss the philosophy. You can read more about it in some philosophical papers of mine, but it's essentially that counterfactuals don't make sense. You can have pretend counterfactuals based on something else that does make sense, but just the counterfactual itself, I think, doesn't make sense. And there are good alternative accounts of causality, including causal process theory. And as I say, some of this material is published in the Spanish Teoria. Okay. What I'm going to talk about really is practical concerns. or what I'm stirred by mostly, though, are practical concerns. And in particular, that the demand for counterfactual reasoning has led to this huge amount of endorsement of randomized controlled trials. And I think randomized controlled trials are, as we all know, they're extremely limited in what they can provide. So as a device themselves, RCTs only provide unbiased estimates. And what you can prove is that you can get in an ideal randomized controlled trial, that's one where orthogonality is a guarantee, which is certainly not the case in any real life one. What you can get is an unbiased estimate of an average treatment effect. So it's just an average, and it's across a population. And it's almost always a population that's elsewhere and elsewhen from the population you're interested in. So they are not relevant to what happens here and now. And they just aren't. I mean, they're just facts. Right? I mean, you have a fact about, and you have a good unbiased estimate of an average treatment effect for a particular population. How does that get? And that's not my population now. How does that get to be relevant to my population now? Well, that doesn't come in any way from the randomized controlled trial. This is all just things you know, right? The only way you can get there is by lots of theory and lots of additional information. But you can't do it without lots of theory. And my view is that if you're going to use theory, then I mean, but it always depends on what theory you actually can come up with at the time and what knowledge is available. But if you're going to use theory, it's best to more directly use what we've been calling middle level theory. Okay, and use you can use it, and there's a lot of middle level theory available. And it can get you something which is a model which is directly about the population that you're studying at the time. But it's a model you construct. I mean, it's not a model you know after the fact, okay? But it's a model we're going to use for prediction. So middle level theory, this term is a real hodgepodge. Different people use it for different purposes in different ways. I'm going to talk today specifically about two kinds of middle level theory. One is middle level causal principles, and the other is middle level p-talks. So I'm going to note that a theory of change, or whether it's a causal process tracing one or some other kind of theory of change, can be constructed at various levels of generality and abstraction, and that I'm going to endorse particularly something that's sort of in the middle as a good device. Okay. So middle, well, it's middle between, on the one hand, the abstract and the concrete, and on the other between what universal principles or wide-ranging principles and very particular and local. Middle level theory isn't a natural kind. It's just a term that we can use to help us sort of think about and point to a lot of work that's done both in real life and in science that we can call on. So think about high level. Agents act to maximize their expected utility. That's fairly high level. It's supposed to be wide ranging, and it uses abstract language, expected utility. Okay. Then there are middle level versions of this, more move down the level of more concrete versions that are what in philosophy we call concretizations of this high level theory. So agents act to, so the other one was, remember, agents act to maximize their expected utility. And now we have people respond to incentives. So that's a particular kind of way of acting to maximize your expected utility. A slightly lower, I would still label it middle level. People offered conditional cash transfers to do something tend to do it. That's responding to incentives or acting to maximize your expected utility, probably. And that's, or parents enroll, even slightly more concrete, parents enroll children in school if offered education condition cash transfers. These are range restricted. You don't really expect them to hold nearly as widely as the more abstractly expressed ones. And they use more concrete language, sometimes fairly, down to by what I think very concrete language like education condition cash transfers. Then there's really concrete and particular principles. For instance, here's a very concrete instance of the abstract principle: agents act to maximize their expected utility, or people tend to respond to incentives. Okay, so in Brazil's Bolsa program, conditional allowances given preferentially to female heads of household through citizens cards that operate like debit cards, where the funds can be withdrawn in more than 14,000 locations, induce parents to enroll children in school. That's a very concrete principle that is a kind of summary of what was hoped to be the case for Brazil's Bolsa program. So these very concrete ones, the very low-level ones, tend to be tied to specific places and times, and they use concrete operationalizable language. They're the kind of things that you can really imagine fairly immediately how you might go out and test. Okay. Now, for middle level theory, and I think the two kinds of middle level theory I'm talking about are extremely useful in development planning and evaluation. And I've been focusing on development simply because part of this work was done under the auspices of the Center for Excellence in Development, Impact and Learning, which was a DFID center, Department for International Development in the UK. So this particular version of the work was done thinking about development planning and evaluation, but it needn't be just planning and evaluation and development. It can be across policy areas, and I think more widely. So middle level theory can do a lot of jobs. It does a lot of heavy carrying. First, the one I've always been interested in, which is predicting effectiveness in local settings. So how do I begin to think about what will happen when I act? But it can further suggest program design features. It gives you information for monitoring if you're going, and once the program's been implemented. It provides assumptions to be tested in an evaluation. So a post hoc evaluation, did the program do more or less what it was supposed to? There are assumptions to be, there's some assumptions you can test in evaluation. It can help identify evaluation questions, and it can help interpret evaluation findings, including about where such a program might work elsewhere. Now, my own view is that it's not generally the way to go. That generally, rather than trying to go from it worked there to it works here, we should just try to construct a direct argument that it works here by constructing one of these p-talks. But anyway, these are a number of things that middle level theory can help us do. So let's start by, excuse me, let me have a sip of water. Explaining something about what is meant in this work by the term middle level causal principles. They go by other names sometimes. John Elster calls them mechanisms, and I think that's also what the realist evaluators call them. And John Stuart Mill called them tendency principles, but tendency principles needn't be middle level. But the kind of principles that I'm thinking of are often very familiar behavioral principles. So people respond to incentives. That's a familiar behavioral principle. Okay. Mothers are less likely to give in to temptation spending that's intended for the children's welfare than are men. Nurses, teachers, etc., tend to work on their patients' or pupils' interests. That's one we rely on all the time. We just take for granted that cateris paribus, the nurses will look after their and care about looking after their patients. Or people don't like being sent to jail. That's a familiar behavioral principle that is not always true, and it's not always dominant, but it's it is a natural, widespread tendency. Okay, now these are also the result of social science, can also be the result of social science research. So nudge theory, indirect suggestions influence behavior and decisions. There's been a lot of actual real social science around nudge theory. Implicit bias is, I think, a social science concept. The placebo effect, or one from economics, skill loss perpetuates periods of unemployment. Okay, so now these principles generally don't tell what will result. Okay? They describe rather what the cause tends to, which is why John Stuart Mill called them tendency principles. You may have to trigger the cause, and the indicated effect may not be the observed outcome because other causes also influence it. And nevertheless, the point of the principle is that we think the way to think about it is that the cause is still pushing the outcome in the direction indicated, even if there are other things. Once triggered, the cause it pushes the outcome in the direction indicated, even if that's not what you see, because something stops its action, or the effect is its natural effect is overcome by the operation of other causes. I'm not quite sure whether I have this on the slide, but when I said these are widespread, they tend to be, we might think of them as individual or institutional dispositions. They're not always individual or institutional dispositions. It's not the case that they're always present. And then there's this further fact that they don't always act. You might need to do something to trigger them, and it might not be possible to trigger them. And then there's the final fact that even when they do act, you very seldom get exactly what the principle says is the natural outcome of that cause. Okay. So I want to talk about constructing these are middle level causal principles. Remember, I said that I was going to talk about middle level theory of two kinds. And the first is middle level causal principles, and the second is middle level p-talks. What I now want to do is to talk about constructing middle level causal process tracing theories of change. So that's the second kind of middle level theory I want to introduce. And then the two fit together. That's why I'm talking about them both at once. So I want to talk about constructing middle level p-talks using middle level causal principles as guides. Okay. So, and I'm part of what's important to me about this as an addition in the philosophical literature to causal process tracing theories of causality is I don't think that the usual philosophical literature pays sufficient attention to the need for these middle level causal principles along the way and the importance of what they can do for us. Now, as I say, I think in the realist evaluators do make a fuss about them, but they don't do so much. They tend to think only about the mechanism or the causal principle that connects the initial cause with the final outcome, whereas a causal process tracing theory of change has all the steps in between. So as I said, this is a conglomerate of ideas that some of which are already familiar to you, or probably most of which. So in constructing 10 steps to constructing one of these, so you could get to see what it is first, I think it's you should specify the overall middle level theory. And that's often what evaluators, realist evaluators mean by the mechanism of the intervention. The overall theory is what the program is expected to achieve and why. So for educational conditional cash transfers, the middle level theory is something like this. Cash transfers conditional on children attending school increases I've got the tenses wrong here, don't I? Not the tenses. I don't have the subject predicate agreement. Conditional cash transfers conditional on children attending schools increase school enrollments. And they do so because households spend in their children's interests, failing strong barriers. So that's the overall program theory. Okay, and the part of the reason for that is what the cache is supposed to do is to overcome financial barriers. Okay, so the next is to produce a step-by-step diagram. Now, if you look in the paper associated with this talk, you'll find a very long step-by-step diagram. I've just for illustration produced only a three-step diagram as an example, but I think the more steps you put in, the more useful it will be to you. You'll see exactly how it gets to be useful as we carry on. So here is a three-step diagram for this program. The initial causes are that the transfers are labeled as education related. The cash is transferred to poor households, and the conditionality of the transfers on school enrollment is announced. And that's supposed to lead to, number two, households deciding to enroll more children and deliver them for enrollment, which is in turn supposed to lead to more children being enrolled. So this is three-step diagram. As I say, you'll see, I think it's about a 10-step diagram that's in the on the final in the written up paper. Okay, so we've laid out, we've given the overall program theory. We've laid out a step-by-step diagram, which are the salient steps in the middle, which is supposed to be affected by what's come before. And then for this, we also need to then describe the causal principles that are supposed to be at work at each step. So here I'm supposing that it need not be a general fact. This is a philosophical point. It need not be a general fact about causation that every time at an individual level, one event causes another. It needn't be the case that that always falls under some general principle. Some philosophers have argued that it must, that there can't be any causation unless it's causation under a general principle, which sort of takes the causal principles as being prior to and being responsible for singular causation. Donald Davidson was famous for that. Now, whether or not there are, just causal happenings that happen somehow arbitrarily, they're not part of the general structure of how nature operates, I don't know. But if you're going to be in the business of trying to institute programs that have predictable outcomes, you better be planning on the kinds of causal steps that fall under causal principles, so that you have some reason to think it will actually happen. So we're interested in cases where there are causal principles at work at each step. As I said, some philosophers argue that there always must be. So let's look at I'm going to talk about two causal principles. There can be many causal principles simultaneously at work in moving from one step to the next. There can also be a choice of causal principles, any one of which might be at work. And I'm going to talk about two principles that are relied on in the step from these initial ones to step two. So if you take 1 and 1 prime leading to 2, that can come under this principle, that labeling a good leads to the increased importance of that good, which leads to increased spending on it, even absent a requirement to do so. That's a fairly standard middle, low level, familiar causal sequence and causal principle. Labeling a good, it increases the importance of that good. That's part of nudge theory, is based on that. And if something's important, then it will increase the spending on it, even absent a requirement to do so. Now, we're going to add in, though, 1 double prime, the conditionality of the transfer on school enrollment is announced. And we have another causal principles at work, that conditioning cash transfers on a known requirement can generally lead to the costs of not meeting, there'll be costs for not meeting the requirement. and that leads to calls into play the substitution effect. That's that increasing cost of a good encourages choosing an alternative. And once the substitution effect is in play, that leads to attempts to meet the requirement. So again, here we have the very familiar low middle level principles that are supposed to be responsible for why you can expect those things that you initiated at step 1 to lead to the outcome we're looking for at step 2. Okay. Now, the importance of describing the middle level causal principles at work, it's not just so that you have some reason to think that step 2 can follow step 1, that there's good reason for it to do so. But that once you've specified what those causal principles are, you're in a much better position to understand what has to be in place for it actually to happen. So the causal principles play a central role in figuring out what information is needed for each step to occur as it's supposed to. So I want to talk about what kinds of information that is. So you've got the next thing just a particular order in which to do things, but I think if you've got the causal principles, it can help you figure out the kinds of things you need. One of the things you're going to need for any cause to produce its effect is that the correct support factors are in place. So the actions that are cited as the cause or a cause, or this is what we're going to do in order to get that, those actions are seldom enough to produce the influence that's expected. This is familiar. J.L. Mackie talked about it a lot in philosophy, that we usually only pick out the salient cause, but there's lots of other stuff going on in the background. The philosopher's favorite example is striking a match. Well, striking a match can get you a fire, but you're assuming that there's oxygen in the room and no sprinklers that come on and douse it the second it starts to light. So the actions cited are seldom enough to produce the influence expected. They need what I call support factors. These are also called moderators or interactive variables. So the intermediate steps are often called mediators, and these support factors that allow any one step to lead to the next one are often called moderators. And as I said, I call them support factors because they're what help the cause, which has the tendency of the cause that helps it to actualize. Okay, so here's some examples. Remember the causal principle that one of the causal principles at work from getting from 1 to 2 was that 1 and 1 double prime imply 2. That's under this principle. Conditioning cash transfers on a requirement induces the substitution effect, which induces attempts to meet the requirement. And to get that to work, it's not just enough that you condition the cash transfers on a requirement. That's not enough to get a substitution effect. The conditions have to be conveyed and understood. Okay? And there has to be a credible threat of enforcement. Now think about the step from 2 to 3, that presenting a child for enrollment is supposed to lead to the child being enrolled. Well, that depends on the fact that the school is competent to enroll students and that there are places available. So these are the A's and B's here. The little A's and B's are some of the support factors that are necessary for the salient cause that the thing you've labeled at the various steps to actually lead to the next step. So there's a caution I want to raise here. The standard caution: chain is only as strong as its weakest link. That if you've laid out a step-by-step diagram, as I said, ours only has 3 steps, but that you could profitably and usefully usually fill in lots more steps, each one of which has to happen in order for the effect to be the cause to actually succeed in leading to the effect. Well, each of those steps, the must have its support factors in place to produce the next step. Or else, if any of the support factors is missing anywhere down the chain, the whole process collapses. That's why this is such a, I think, such a useful tool to map out these causal principles step by step, and then map out the support factors, because it gives you a wealth of information already about things that really have to be in place or find substitutes for if the process is going to carry through. And some of them, you already naturally took into consideration, but many others, if you haven't done this explicitly and thought it through, you're likely to miss out on. Sorry, if we have more time later, there are lots of famous examples. After you've added the support factors, so, I think it's useful to think in terms of derailers. So derailers are things that intervene to prevent the effect. So in a sense, what's the negation of a derailer could be a support factor, of course. But the way I think of it is support factors there, there's enough now. I mean, if all this is in place, the cause will try to, the Australian expression, actually, I'm sorry, I know we're talking in Australia, I should say that the Australian expression for this is the causal oomph, right? There's enough there to have the causal oomph to make a contribution to bringing the next step into effect. But then something happens to derail it. Okay. So the household accepts the conditional, the cash transfer, accepts the cash transfer. It understands it's meant for sending children to school. It intends to do so. These are all good support factors that are there for leading to sending the children to school. But then the derailer comes along, that they give into temptation spending or yield to other priorities, even though that's not what they intended in the first place. So that's an example of a derailer. Another one that my colleague Eileen Monroe talks about with child protection is, you've had a program in place working with the mother, and really everything's going very well in figuring out her figuring out, and with the support of her sort of background network, how to get on better with the children. And then suddenly her abusive boyfriend moves back into the house. Okay. So now you've got the idea of support factors and derailers. Think about safeguards. So a safeguard is just a wall that's to exclude derailers. So there are all these derailers that might happen. Some are probably improbable, you don't have to worry about. You've thought of, well, lightning could strike. We're not going to put too much investment in protecting against that. But the ones that are likely, it's when you're thinking of implementing the program, and you'd like to know what kind of safeguards you could put in against those. So one safeguard in this case that is often used is mothers may be more concerned about the education of their children than fathers, so they tend to be less likely to give into temptation spending or yield to other priorities. This is a theory, at least, right? So the safeguard is that give the conditional cash transfers to mothers in these circumstances. And we all know that these safeguards can be not appropriate in certain circumstances, of course, and they can also backfire. Anyway, in the end, we get a much more complicated picture like this. So what I tend to do is to take, I put the salient causes in these square boxes. We had the square boxes, one with an arrow between them. The arrow meaning tends to lead to, and then all the support factors that must work with a particular cause in order for it to lead to the effect. They're grouped together around the cause in a big circle. The point of that is to show, which causes those support factors are helping under which principles. Remember, we could have more than one causal principle, so you might have different groupings, and that matters. Reason for this is, as an aside, since you folks do this more serious detailed modeling, if you've got directed acyclic graph that has, the causes and then the effects and all the causes, all the parents leading into a particular effect. You can't tell the difference between what are totally separate causes, each of which is enough by itself to contribute to the effect, and the ones that have to work together. So you can't tell the difference between ands and ors. And this is just a device, a visual device for showing you that we need not only to transfer the cash to poor households, but at the same time, right, along with that, we need to make sure that the transfers are low cost to the recipients. Okay, so I put all the support factors in a circle together. The derailers have these jaggedy edges, and the safeguards look like little walls protecting them. This is just all a device for conveying information, but it seems to have been useful to do it this way, to do it all visually in one diagram as far as you can. This diagram doesn't have the causal principles explicit in it. You'll see in the longer paper that there's also an arch with the causal principles on them. Okay, now don't forget to allow for causal loops. So causal loops can be positive or negative. In our case, here's a positive one, that the more children that are enrolled causes, that little arrow with a C in front of it, I thought I took all the C's out, but I tend to use an arrow with a C in front of it to mean that just doesn't follow in temporally, but or isn't just correlated with, but that this is it's a induces or causes. Okay, so more children are enrolled induces, and in fact, eventually more children will be withdrawn, and that should induce the cash transfers to be stopped for them. And then if that has wide notice and wide understanding of the reason, that will induce the credibility of that cash transfers will be stopped if the conditions aren't met, and that in turn induces incentives to keep the children in school, which induces more children to be enrolled. So here we have a positive feedback loop. And of course, there are well-known negative feedback loops, lots of those. The next thing, I think that it's incumbent on a designer of one of these things to do. Yep. Michael, did you say something? Okay. Is to specify the expected range of application. Where should you expect this middle level PTOC to apply? And again, one of the reasons for this nice graphing everything out is that the indicators come from the overall program theory and from the middle level causal principles and from a survey of the supporters, derailers, and safeguards. So for instance, the program I've been describing is risky anywhere that the middle level principles don't work. I mean, if you just can't get those middle level tendencies into action, you shouldn't expect the program to work there. It won't work anywhere that there are support features, factors missing that you can't substitute for. It won't work, probably won't work anywhere where there are unguarded derailers are likely. So think about the range of application here. The overall program theory was that conditional cash transfers remove financial barriers. So they won't work where households are failing to send their children to school because they think the school's low quality, they don't trust it, or they disapprove of school education, okay? Rather than the households aren't sending the children to school because they lack resources. That's fairly obvious, but it's surprising how often when this isn't graphed out, these programs fail for what are post hoc look like obvious reasons. Think then about support factors, derailers, and safeguards. The transfers are to be low cost to recipients. There should be school places available. So it won't work where there's no way to achieve these. Okay, then draw some implications for evaluation questions and monitoring and evaluation indicators. And so here's drawing implications for evaluation questions. If you want to evaluate post hoc, did the program do what it was supposed to? You can look to see whether there were school seats available. Did the beneficiaries understand the conditions, since that's one of the support factors? Were the conditions monitored and enforced? So finding ex post that essential features were missing is evidence the program had little responsibility for the results, even if the expected results occurred. Then you can draw implications for monitoring and evaluation indicators. Okay. So the number of beneficiaries participating, parental knowledge and understanding, verification of the receipt of the transfer, how well the conditions are monitored and enforced, outcomes on school enrollment and attendance, etc. And then there will be indicators at various levels. So this now I'm going to close with just describing what I meant by saying you can construct these P-talks at various levels. And particularly I think of two, roughly again, let's just think in terms of two levels, but there's no fixed divide by what that means. The middle level P-talk is meant to apply across a limited range of settings. So usually they're in development, we're trying to design programs that we think aren't just going to work here, but will work widely across a certain range of kinds of situations. And that's the middle level P-talk, and it's meant to apply across a range, but a limited range of settings. And then for any particular case, you really have to concretize it to see what the middle level P-talk amounts to in this case. Remember the discussion way back at the beginning of the talk about the Bolsa program in Brazil, where you really had to concretize what you meant by making the cash transfer. Okay. So the middle level P-talk suggests general types of monitoring and evaluation indicators that may be adapted to specific contexts through thickening. That's going to be the case with everything that you'll have. The middle level one is at a more abstract, uses more abstract vocabulary, more general terms. And in order to think about what happens in this case, you need to figure out whether and in what ways those more abstract terms can be concretized, and see whether there are the right kinds of concretizations possible in your situation to actually expect the program to work here. And then that's what needs to be implemented. Okay, so to draw implications for future program design, this is in the case I said where we're thinking about a repeatable program, one that you've got a middle level theory for, that's you're hoping will apply across a range of circumstances, and you've actually instantiated it in a couple of places and slightly implemented it in slightly different ways in different places. And does that, having evaluated how and whether it worked in those cases, does that help you in any way about other settings? So I think it does so by sort of a process of abstraction. So you have the findings in an observed setting, and that helps confirm the middle level P-talk, and also it might also help revise the middle level P-talk. Right? But what the findings in observed setting are supposed to be a concretization. You have findings in an observed setting that back up a very, very concrete causal process theory of change there. And you see that as a concretization of a more middle level theory. And then when you come to a new setting, you've got the middle level theory, and you figure out what would be an appropriate concretization in the local setting. So you can apply evaluation findings from one setting, can be of use in another, but there's no direct horizontal transfer. I mean, that's a dumb way to go. Rather, You have to actually see what's really going on here. I mean, what are the causal principles under which this is operating? And then what do those actually look like, and what does it take to get those to operate over here? Okay, so the implications of findings is you're finding in the observed setting, I think I've just said this, households, so here's something you might have found in an observed setting. Households didn't take part because the transfers were made to bank accounts and they didn't have bank accounts. In the middle level theory, transfers should be made in a way that makes them accessible to intended beneficiaries. So in new settings, you know, the time and places of transfer need to be convenient and accessible for recipients there. That's why I gave that long story about how the transfers were being made in the BOLSA program. Okay, now, what about general credentialing of these PTOCs? I use the word warranting. My friends at Settle, the DFID Center in Britain said they didn't understand the term warrant. Making something warranted or providing reasons to expect it to work. Well, how do you credential it? So credentialing in this case was going to come from a huge variety of sources. Okay? Requiring a broad mix of methods. I mean, after all, you have to credential that there are these middle level causal principles, some of which we've got from social science research and are credentialed by social science research. Some are just credentialed by them being so well known that they don't need that anymore. Then you know what the kind of support factors are, whether the support factors will be in place, etc. Okay, the better the support for each component of the PTOC, the stronger the credentials, and it can also be tested by looking to see if the program works when it accords with an appropriately thickened local PTOC. So you've got this is just in a sense induction. You have a middle level PTOC and you look to see whether an instance of it works. Okay. And this can lead to a process of mutual adjustment between the middle level and the local level, and that continues as theory is used in designing and implementing further cases. Okay, so final advice, and I'm just not sure how many of you this is relevant to, but if you're designing programs for repeated use, building a middle level PTOC can be hard. The causal process tracing theories of change have far more information in them than normal theories of change. And it needs a lot of theorizing and research. But I think that it's irresponsible to duck this job because local decision makers are generally not in a good position to figure out what must be in place if the program process is to carry through there. You're after all the guy who's designing and trying to sell this program. Should be in the best position to figure out why on earth it should work. So you need to assist them by providing maximum information. And I think these middle level PTOCs really provide quite a lot of information. Now, if you're deliberating at the local level, I think you need to build or get some people to help you build a good local level PTOC. If your decisions are to be both reliable and credentialed. And a good middle level PTOC is an invaluable starting point. Now, why do you want a good local level one? Well, because even if, whether you build one or not, or want to think about it, what it's doing is it's mapping out what must happen in the world if the program's going to succeed. So my feeling is always, everyone's always doing a kind of cost-benefit balance here, but if that's what needs to happen in order for this program to work, I'd better do my best to figure out what that indeed that can happen here and what I have to do to get it to do so. So a good middle level PTOC is an invaluable starting point for building a local one, because then what you do is you thicken that to fit the local circumstances. But doing that requires local knowledge, of course, and that often takes additional research. The different people always want me to remind everyone that it's best to do this with key stakeholders. So thank you.
Thank you so much.
Now let's see. Pause share. You
Hold on.
share. No,
Let's
stop share. That's what we want.
okay. Shall we open it up for questions? Feel free to unmute yourself. If you prefer to type something into chat, that's also totally fine. Yeah, Diana.
Thank you. Thank you, Nancy, for the talk. It was very interesting, and I really enjoyed the fact that you were presenting all your examples coming from cash transfer programs, which is exactly my topic of research. So I am very familiar with all the literature.
Well, I don't really know much about them. I did this work with 5 other people, one of whom knew quite a lot about them. So
Sure.
sorry.
Yeah. I'm not gonna ask you a tricky question about it, but it was more. So what I understood from the beginning of your presentation was that you were trying to propose an alternative to RCTs with this theory of the causal link of how the programs should work. And I just want a clarification on what I got at the end of the talk is more, how do we think about the programs and how we can expect them to work in a very more comprehensive way through the P-talk process. But I don't see how we could see how, like, to be able to measure the impact of a program, we will still have to, it's not an alternative, but instead, to me, what I learned is it's complementary instead of an alternative. So is that right, or?
It depends on what it's an alternative to. An RCT doesn't tell you, so I have a strong view here that I'm prepared to defend. An RCT tells you nothing. If you study a given, if you study me, you learn about me. If you study I'm sitting in Oxford at the moment. If you study a sample of an Oxford, random sample of an Oxford population, you learn about that random sample. And if you really did it randomly, you might think you learned about the population of Oxford. So when you study, what you learn in a study is what you study about. If you want to use those findings elsewhere, then you've got to do more work, and that work is done by something other than that study. So that study can be really useful, right? It can be, for instance, an instance or an inductive inference, but you have to watch out for inductive inference. We always use the examples in philosophy of all swans are white until you get to Sydney Harbor. So an RCT can give you, unlike the method I described, the method I described can give you a good prediction of whether something that you want, will work here. Okay. An RCT will give you an unbiased estimate of an average treatment effect size there. Okay. Now, what you'd ideally like is to know both what will work here and what an average treatment effect size is for it. There isn't any way to do that, right? There's no good reason without tons and tons of other theory to think that the effect size over here is at all relevant to the effect size over there. And in fact, so here's that when people start trying to figure out, well, how would you adjust it? I mean, it's probably not going to be the same. One of the reasons it's not going to be the same, I guess you know this, is that the effect size is, the average treatment effect size is clearly a function of the distribution of the support factors. And so you could take the RCT there and combine it with a lot of additional information, like what the support factors are there, what the analog of them is over here, and what the distribution of them is over here, to readjust to get a new effect size for over here. And we see that being done in some of the work by people like Judea Pearl. But anyway, that's my feeling, is that this is not a substitute in the sense that it won't. So the short answer is you can't get an average effect size here out of this, but then I claim you can't get an average effect size out of anything without a lot of additional theory. A lot of it involves the very same factors that you need to do a p-talk over here. But I agree, I'd like to do both. I mean, I'd like to have both kinds of information.
Because if you are talking to a donor who wants to, run a program, they are not like the theory sounds amazing and it's really good, but then they want to at the end know if the program work or not. And I should like the problem you're addressing is what we call the external validity problem, which is, you are implementing something similar somewhere else with different conditions, and then you don't know what is going to happen. So you're trying to set up the best assumptions, and then you can run an RCT, let's say, to try to test some of the mechanisms that you are interested or whatever. But at the end, you want to know the magnitude of the effect, which your model, like your proposal model, doesn't address. And that's why I think it's more complementary instead of.
I think it's important that we have to be realistic about donors can want things that they can't have. And you can give them, you can be in a good position to estimate effect sizes in new populations with a very great deal of information. And I mean, I know a couple of ways of doing that, and they all require a great deal of information. And in addition to that information, you have to know that it will actually be able to work here. And then you could get the effect size by calculating, what the probability of these support factors is, what the probability of the derailers is. But I don't think I just think it's a real problem about the overpromising, and when there's just no logic that allows us with the information we usually have to actually predict effect sizes. You're winging it. So that's mean, but philosophy, I'm prissy about what the logic of the pattern of inference is. And what I actually think goes on is that people, probably like you, who work on the ground, have very, very good, what's the word, Spitzgefühl for which kinds of situations are sufficiently like the ones where the RCTs were done, that there's not going to be a lot of adjustment in what the support factors need to look like and what their distribution is and the derailers to make the effects to produce very different effect sizes. So that I think a lot of it relies on a kind of implicit practical, on the ground practical intuition about similarities of populations. That's my bet about what's actually going on that allows this process to go through in a kind of slightly responsible way, is that we're actually relying on you to know things that you might not even be able to articulate, or that would be very slow to articulate about exactly why and exactly what ways that are relevant. This population is like that one. But I don't know if that sounds plausible to you, that more that you're relying on than than the RCT and vague hand waving about this population being like that one.
Yeah, well, I think at least for me, it's important to have a quantitative evaluation to quantify what's the effect of a program in the outcomes that are attended. But I don't know, if there are more questions, I'm happy to kind of.
Yeah. Okay. So anyway, I think the difference between us is just that I'd love to have a quantitative prediction, and I just think that the ones I've seen are seldom they're seldom well credentialed. That the start of the process is very, very well credentialed, and there are some RCTs and they're done very well, and the meta-analyses or the syntheses of them are done very well. And then when it's actually having to spell out the arguments, about how it gets over here, it relies an awful lot on well, the process of inference gets vague. That's what
I can see that, and I can see the value of this when someone is trying to design a program and to convince implementers to do it in a particular way. Yeah. Thanks.
Thank you.
We have Nancy, as long as you're happy to stick around for a little while longer, unless you have to go, of course, that's totally fine. But if you are, does anybody else have any questions?
Yeah, I think it's important that was a wonderful, that was the right question, because the drawback to this is that it doesn't give you an effect size, and you then get an effect size by having to put probabilities on these things, and
Right. And whereas, in frameworks like Judea-Pearls, of course, they start with the assumption that there is an average effect size, and then the whole exercise is to estimate that properly, implement it in some way.
well, Pearl has the the nice ways of reconditioning your probabilities depending on the distribution of the support pattern. It's the sort of standard thing you'd expect, that how to adjust the effect size from one population to another, assuming that the same causal principles hold in the new place that hold in the old place, and that they are all called into play.
Right. Yeah, there's very little practical guidance. So we have a question in the chat box, actually. And the question is, I can read it out, but if you'd like to read it as well, Nancy, it's in the...
I have to get my other glasses to read.
That's okay, I can read it. It says, it reads, many more speculative policy interventions, i.e. various kinds of nudge policy, are founded on middle-level causal theories that are much less well understood and accepted than utility maximization. How does a P-talk deal with the hidden or third variable problem in these more speculative scenarios?
I'm not quite sure what the third variable problem is.
Confounders or something unobserved or unknown, perhaps.
Well, I don't think it's a problem. The general principles of nudge theory, whether or not any particular claim that this is a kind of suggestion that's given in the right way, that you call the principle into play, is so. If the third variable problem is confounders in establishing a causal principle, the problem with these principles is not that they're not established as ones that can actually obtain and do actually obtain fairly regularly here or there under some circumstances. The problem with them is that they're not like the law of gravity, that somehow that you can depend that principle is always going to work, and it's always going to work in this way, and it doesn't need triggering, and nothing gets in its way. The only thing that gets in its way is that there might be other causes at work, like a magnet pulling something up. These are not like that. So it's not a problem of that. Third variables, confounding variables with respect to whether it's it's a good causal principle or not. But there are all sorts of factors that you can get in the way of it actually operating, and all sorts of things that are needed to get it to operate, and then all sorts of things once it's started to operate that can get in the way. And that's what I think the P-talk is for, to sketch out exactly. Now I'm going to put the opt-in, I'm going to make the choice opt-out rather than opt-in. And I'm going to write a big paragraph, and then I'm going to say, check here if you want to opt out. And I'm going to put that in the post. And then what's going to happen? The person's going to throw the post in the rubbish. The person's going to, etc. So the P-talk is actually designed to try and figure out whether, what's going to happen step by step in that case. Maybe that wasn't the question now, but sorry, that's the way I was thinking of it. Just like this famous California school class reduction size. Well, great idea, pass legislation, provide some money so that you can cut the class sizes in half, and see what, and things are going to be really good. And if you want map out the PTOC, well, you're going to pass this legislation, then what happens? Well, the schools are going to have to advertise for teachers. All right, the teachers, prospective teachers, are going to have to answer the adverts. Oh, there aren't enough candidates to answer the adverts. All right, I mean, it's that kind of thing that I'm thinking of being the same in the nudge cases.
Right. Right. I have a question about cases in which you can reasonably assume that a system has properties that make it kind of inherently unknowable. So, so in a lot of cases, these logics of causal inference, and for example, an average causal effect, the idea of an RCT, and relying on the information that you generate from that to design a policy and intervention of one kind or another, doesn't seem to comport or deal with very well particular kinds of nonlinear dynamical systems, for example. So if you have, various kinds of feedback loops of whatever kind, I mean, the one thing that you can probably guess about those, if they're chaotic, for example, is that the amount of information that you can have about what will happen out to some time horizon is bounded by definition. And so what do we do in cases like that, apart from kind of adopting maybe like some control engineering principles or something where you say, I can guarantee you that within 5 years, we're going to be dealing with a different world. And so part of the money for the intervention has to go into keeping the bowling ball between the gutters or something. I don't know. What are your thoughts on that kind of case?
I don't have any better thoughts than those ones you just said.
Okay.
Yeah. The things that I've been looking at are not chaotic systems. It's not clear to me that most of the kind of policy issues that I've been looking at, child protection or development, education, are anything like chaotic systems. I think ordinary feedback loops are very, very common, but that's not the kind of problem you were thinking about. But I do think that just ordinary feedback loops are a problem, and you do get those by trying to think about not just the PTOC that connects, how you connect the cause with the effect, but by doing a larger causal diagram that thinks about, the very difficult issue of, well, when I've got this cause, it can lead, to the next step that I want, but what other next steps will it lead to? And what other next steps does that lead to? And so forth. So that there more information does help, right? I mean, you just draw out a larger and larger causal graph, and then you can see some unintended side effects. And you can also see even when the unintended side effects are not only side effects, but looping back and so forth. But that's not your chaotic cases.
Right.
Is that it?
Exactly. Thank you. Okay. Should we call it a talk there? And unless there are any burning last second, no? Okay.
Or any helpful suggestions? You can write me if there are, please.
Thank you so much for what was a wonderful.
Phil Dow really there?
Sorry.
I see the name Phil Dow. And he, Phil Dow is a philosopher who did causal process tracing. Is that the right Phil Dow?
Yeah, that's me.
Hi. So here's a man who did some of the fundamental philosophical theory on causal process tracing, who's come along. So my work is on causal process tracing is kind of development from the same Wes Salmon and Phil Dow, but going away from the kind of physics orientation of DAP. So thank you. We've got, I didn't give any of that background because I thought these are practitioners, not philosophers mostly.
I'm glad to see you're still putting it into action.
Okay, good. Well, that's a treat for me. So thank you, Michael, for organizing it, and I really would appreciate any comments because we're still working on this, of course.
Yeah, it never ends.
Yeah.
The academic work. Thank you so much again, and we hope to see you down here as soon as possible.
Okay, super. Thank you, everybody.